So the next step is we insert on a project that's modeled, and we've been asked to do the modeling for the seismic bracing. We insert all the seismic bracing in the model, and we coordinate it with the model. So we put in all the brace arms. We can take it so far as to also do all of the hangers for the systems, and we'll talk about the other modeling services that we can do. But at a minimum, we can do the brace arms and also show if you're not familiar with it, this halo shown at the top of the brace arm is the actual anchor spacing required to remain clear of other adjacent anchors, so that the anchor remains valid from an engineering standpoint. Very common in the state of California. I'll talk about that more in a little bit. Integrated modeling and engineering design services that we do. This is very common, that this entire menu of services is adopted on projects, especially here in the state of California. If it's an OSHPD job, we'll do the seismic bracing with the anchorage coordination. We can also do the vertical supports for all the distributed systems, riser supports for the supplemental steel, so that this is not only the modeling, but it's the engineering to back all of this up in accordance with the IVC requirements. So the supplemental steel and pipe clamp anchorages for the pipe risers. We can do all the point loading and show the point loading within the model, and I have an example of that I'll show you. Thermal pipe stress analysis and integration of that analysis into the model. Flex joint design for both seismic and vibration isolation, and integration of those into the model. I've got an example of that for you. Vibration isolation design itself and material supply. Floor and roof mounted system supports. We do those all the time. Prefabricated walkways and crossovers is something that's becoming a large part of many of our projects. For architectural systems, we have a full division of engineers that primarily focus on cold form steel design. That would be steel stud design for those people that are unfamiliar with the CFS term. And we also do acoustical ceiling design. We also do blast protection design, which is very big in the on government projects. And then lastly, custom engineered support solutions, which I've got some examples of. So show you some examples of some of these services. Vertical support engineering and integration, we start off by creating what we call our vertical support construction documents, documents that basically show how to create the vertical supports for all the systems, whether they're single hung or trapeze, what the width of the trapeze is, what the trapeze material needs to be comprised of, the total allowable weights, and how the widths change with the weights. We create tables that are guidelines for the contractors that tell them if this is the schedule of utilities you have on your trapeze, this is the size of your trapeze, your rod size, your anchor at the top of the rod, everything that they need to know to construct that trapeze or single hung support. And here's a blow-up of one of those tables where it gives, here's the size of the utility, this is all the loading conditions, and then it goes through and breaks down for them the trapeze members, and then breaks down also the anchorage. So in this case, if they could start off with an insert, and if they miss their insert, then here's the three alternate connections that they can make to the structure. And then we can also, as I mentioned before, integrate all of that into the model. The only thing that we ask if we do hanger support design is that the contractors provide us their layout for the hangers, and then we can insert them into the model. Our guys are not mechanical and plumbing code experts, and so we would want the contractors to provide us guidance for what the hanger spacing in that realm. For point load diagrams, for those of you that may or may not be familiar with that, point load diagrams are becoming a standard requirement across the country from structural engineering firms. Very, very common. It is a standard requirement on OSHPD jobs. And what that is a drawing showing where every connection by the suspended utilities in the building occurs on that structure, and then in addition to that, what is the load of that suspended utility at that point of connection. So it basically shows it just looks like a bunch of dots, but as you zoom in, this is I zoomed in on this area for you, so you can see it's a circle. This is color coded, so this load is less than 50 pounds. It's a P, which would be a plumbing connection, and the 44 is the loading reference number. And so this is a total map showing where all of those connections are made and what the loading conditions are, and it's specifically for the structural engineer to check the structure to verify that the structure is not overloaded. He'll come into some of these dense areas and look at those loads and verify and verify that the deck is not overloaded on the project. The next thing, another service that we provide is flex joint design and integration. We do this a lot, where we'll design the flex joints at those seismic joints, for example, and then we'll integrate those designs into the model. This is actually we have a project currently that I don't want to name here in Northern California that has very substantial movement at the joint, so we had to design some very specific joints for it. This is not it, but joint design is an art and a science in and of itself. But so we can size the flex, and then we can also integrate the bracing and everything in order to complete that joint within the model itself. Then here are some additional BIM services. Don, did you want to cover this slide?
Sure. There are four. Hang on a second. There are four services that we have outlined here that are things that we can do in conjunction with your work with ISAT. And the first one is called Drawing Changes Report. Very simply, this is taking a set of drawings at a certain revision and comparing them to a subsequent revision. So a good example would be you have an 85% bid set, 85% CD bid set of drawings that you bid against, and then the final set, the 100% CD comes in, and you just want to know what changed so you can make sure that you're still comfortable with your bid prices. Basically, once we have the two sets of drawings, we will create a comparison of them, create a report, and you'll get a detailed report of what is different drawing by drawing with both graphics and clouded changes. The second one, a 3D BIM model, is just what it sounds like. I think that most people here are familiar with what that is. That is a construction project where the owner or the general contractor would like to have a full three-dimensional model of the project. So that can include architectural, structural, mechanical, electrical, plumbing, and fire protection, as well as the site and site utilities. And included in that 3D model would be a constructability analysis and report. So that would include both the clashes, the physical clashes that may exist between parts of the design, as well as sequence clashes or clashes of assembly of the building. You would also be able to have a printed report in 2D that allows you to link to the 3D, and then a full binder that will detail out all the work that was done. You own, if you're the person who's purchasing the 3D BIM model, you own all the engineering information that is generated, including the 3D model, all the collision data, all the reports, etc. That can also, by the way, be expanded to include quantity takeoff and scheduling information, 4D simulations, and the like. The 3D MEP trade model is just a subset of the full 3D BIM model. And this is where the design team is going to supply architectural and structural, and you may need the MEP done because the subcontractors on the job aren't planning to deliver that. So you can get an MEP model, or you can get any one of those trades, simply a mechanical model, simply an electrical or a plumbing, or a fire protection model, and in the following formats as you see on the screen.